Hello, class. This is Mrs. Shu, and I'm obviously not in class today, but hopefully you've spent the last 13 minutes working on a problem related to experimental design, specifically that one right there. Um, so right now is the time, even though I'm not there, where you get to hear how I would do the problem. Hopefully today is helpful for you. It's productive. It'll probably be more productive than if I'm actually there, because then you don't have to hear me get off task for whatever reason. So anyways, let's read the problem together first, just because it helps me to do so. Students are designing an experiment to compare the productivity of two varieties of dwarf trees. The site for the experiment is a field that is bordered by a densely forested area on the west left side. The field has been divided into 8 plots of approximately the same area. The students have decided that the test plots should be blocked. 4 trees, 2 of each 2 varieties, will be assigned at random to the 4 plots within each block, with 1 tree planted in each plot. The 2 blocking schemes shown below, or in this case to the right, are under consideration. For each scheme, 1 block is indicated by the white region, and the other block is indicated by the gray region in the figures. Which of the blocking schemes, A or B, is better for this experiment? Okay, so let me think about this. Okay, all right. So I believe that, and I could be wrong, and we'll look at the answer key later. But I believe the better blocking scheme is A, because it takes into account the variable of forest exposure. Variable of forest exposure. More specifically, the 4 plots in block A have equal forest exposure, and the 4 in plot B wait. Sorry, the 4 plots in block 1, right, have equal forest exposure, and the 4 in plot in block 2 have equal forest exposure. Whereas in blocking scheme B, that is not the case. Obviously, my answer might be different than what the answer is according to the AP answer rubric, but we'll take a look at that later. And it's possible that I'm not perfect. Sometimes I get things wrong. But yeah, I think that would be it, especially since my reasoning is that these guys are so close to the forest, and then this block is not close to the forest, so therefore this entire block has the same amount of forest exposure, and this block also has the same amount of forest exposure. And when you block, you tend to block according to a a lurking variable of some sort. And in this case, I believe what they're getting at is the two blocks should have equal amounts of forest exposure to each of them. Alright, so part B. Even though the students have decided to block, they must randomly assign the varieties of trees to the plots within each block. What is the purpose of this randomization in the context of this experiment? Okay, so randomization is to reduce, in general, is you're using it to reduce the possibility of systemic bias of some sort. So in this case, if I were to put it in context, randomization is important because it reduces the bias that could be caused by other lurking variables such as exposure to sun, possibly amount of rain, maybe. Amount of rain. Maybe quality of soil, etc. And the reason, I don't know, I think that should be good enough. And I think we'll leave it at that, and hopefully that is good enough. But I could possibly be wrong. So let's take a look at what the answer says. So essentially what I'm saying here is that randomization is important because when you randomly assign, you reduce the possibility of your own bias, systemic bias, of placing different types of trees within plots that systemically favor certain outcomes. So let's take a look at what the answer rubric says, and I know that this is probably not the best recording session. It is my first one, so just please bear with me. So part A, blocking scheme A is preferable because it creates homogeneous blocks with respect to forest exposure. Okay, there's fancy wording. That's better than mine. Whatever. That is, plots in the same block have similar exposure to the forest. Alright, let's see what their answer is for B. Oh, they have two answers here. Randomization of variety of trees to the plots within each block should reduce any possible bias due to confounding variables. Hey, sounds like mine. Such as fertility or moisture or productivity of the two types of dwarf trees. Okay, so they just had different variables, but I think that should be okay. Or randomization of variety of trees to the plots within each block should even out or equalize the effect of other characteristics of the plots that might be related to the productivity of the trees. Okay, so let's see how this was scored. And you can score yourself, and then I'll also be scoring mine at the same time. A statement that blocking scheme A is preferable. So part A is essentially correct if a statement that blocking scheme A is preferable. Yay! And a good explanation that gets at the notion of wanting homogeneous experimental units, plots, not trees within blocks. Uh-oh. Maybe I didn't mention that. I think I did, though. Blocking scheme A is chosen with weak or no explanation. That's partially correct. Blocking scheme B is chosen, and the student clearly demonstrates an understanding that trees of both varieties should appear in plots bordering the forest, and similarly trees of both varieties should appear in plots away from the forest. Oh, okay. So homogeneous. Yeah, okay. Yeah, obvious. Oh, I'm stupid. Homogeneous just means all the same, right? So yeah. Okay. Oh, wait, maybe my answer is not good. A better blocking scheme, the better blocking scheme is A, because it takes into account the variable of forest exposure. More explicitly, the plots in block 1 have equal forest exposure, and the 4 in block 2 have equal. Oh yeah, no, I think it's fine. Yay. Okay, sweet. So I think I would have gotten an E on this question. Hopefully you would have too. Notice it says here plots, not trees. So you had to have mentioned plots because here it's not. Oh, sorry. Now that's blocking scheme B. Blocking scheme A, right? There is going to be one of each type. So there's going to be essentially four trees, 2 of each type within this scheme, right? And then there's going to be 4 trees here, 1 of each type within, or sorry, there's going to be 2 different types within this first block, and there's also going to be 2 different types here, right? So they're going to compare the difference between the 2 different types of trees close to the forest and the 2 different types of trees away from the forest. That's how this is going to work. So notice they said trees, not plots. So if you said trees, that's a problem. And since I said plots, I think I should be okay. All right. So let's take a look at part B. Part B is essentially correct if the student clearly explains why randomization is important in the context of the problem. Okay. And partially correct if the student understands that randomization reduces bias and explains it in context, but does not make it clear that random assignment may favor one variety of tree. Oh, okay. Or the student has a correct explanation, but contextual interpretation is poor or inappropriate. Okay, let's look at our answer again, or my answer. Sorry, it's not really your answer. Let's see if it's good enough. Randomization is important because it reduces the bias that can be caused by other lurking variables such as exposure to sun, amount of rain, quality of soil. I don't know if I make it clear that non-random assignment may favor one variety of tree, but I'm not sure if they did either, to be honest. Let's look at their answers. The randomization of variety of trees to plots within each box should reduce any possible bias due to confounding variables such as. This sounds like my answer. So I think that it's okay, according to their answer, that mine looks like this. But essentially, randomization is there so that it reduces experimenter bias. Like if it was non-random and you just decided to place trees like systemically, it's possible that you're going to place 2, like let's say 2 of the same trees here in the northern part, and then 2 of the other trees here, and it's possible that the northern part gets more water or more sunlight or more fertility or whatever it is. So therefore, that would favor a certain type of tree over the other. That's essentially, I think, what they were possibly looking for. But I think my answer sounds really close to theirs, so I think it should be okay. All right. Hopefully, you'll be able to do another problem during class, and then maybe we will do another problem some other time. All right. Thanks, and hopefully this was productive for you.